Okay, if not, I suggest that we move on. And the next presentation is on the experimental field DIWAKOPTER, and it is organized by our cooperation partner in the Western Balkans project, which is Hochschule Geisenheim University. And I welcome Dr. David Brunner from the Department of Viticultural Engineering to give his presentation.
So, welcome. Can you see my presentation?
Yes.
And can you see the mouse?
Yes, that as well.
Okay, this is good. Okay, so a very warm welcome from my side. I'm happy to be able to present a little bit what we're doing here. As you have said, it won't be necessary to present the Hochschule Geisenheim because it's already known as a project partner. And the experimental field DIWAKOPTER, the application was done by three departments of the Hochschule Geisenheim. It is the Department of Viticultural Engineering. This is where I am working, and as well as and also the Department of General and Organic Viticulture and the Department of Wine and Beverage Business. I'll give you a short introduction. DIWAKOPTER, what is covered by DIWAKOPTER, and give some examples of activities we do before I will close with a short conclusion. So the acronym of DIWAKOPTER you can see here is Digitalisation in Viticulture. Here we have a V for Weinbau in the German, and agriculture, with focus and possible use of multicopters. Test areas are provided by the Hochschule Geisenheim and by the Hessische Staatsweingüter in Elberbach and by the Zwei Lindenhof Reim in Hohenstein. The project is a quite multi-dimensional project. I've tried to symbolize it here with some slides. There is one dimension, the different crops which will be covered. The first of all, it's the vertical crop, the viticulture. This is the main topic, but it will be extended to another vertical crop, meaning orchards. But it will also be extended to arable crops, meaning wheat and canola. The next dimension, we are working not only on different crops, but working on different levels of sensors. There is one level, I call it not completely exactly a kind of linear or time row sensors. So this is, for example, temperature sensors or humidity sensors or speed sensors, all sensors which result in line graphs if you plot them. The next level of sensors are kind of aerial. It's not correctly written here. I mean the area, not the air. Kind of 2 or 2.5D sensors resulting from RGB and multispectral cameras. So if you take one photo, you get a two-dimensional sensor result. And if you have several channels, you get even a kind of 2.5 result because you have several layers of this two-dimensional area. And there will be a third dimension of sensors, which I will call here spatial sensors. The result of these sensors are 3D point clouds, which are the result of photogrammetric processes or of LiDAR scans. So if you put those two dimensions together, you have you have two dimensions represent. To go into the third dimension, we have another aspect. This is data transmission. On the first layer, we have local data transmission techniques like WLAN or LoRaWAN. I will explain that furthermore. And the next level, we have kind of terrestrial data transmission systems like internet or mobile networks. And this is a new thing for us here. In the third level, we make trials with satellite communication. There is 1-point iridium satellites, which are low elevation orbit satellites. They are turning around the Earth, and geo satellites like Astra, which are geostationary satellites. And the background is there's a lot of discussion about the mobile nets, not everywhere available. Not sure when will 5G mobile nets be available everywhere, and so this could be a solution to fill the gaps. So and there is even a kind of fourth dimension. So you see that we have the cube of these first 3 dimensions, and the fourth dimension are the target groups. So the things we do aim to the needs of producers. So we cover subjects of plant protection and fertilization, also of crop management and documentation. These are all aspects which are interesting for producers. There's another target group, I call it services. So these are consulting services which also need documentation aspects. And we're working with drones and big drones, which probably will be driven by services, which would like to work with those drones beyond visual line of sight. So we have the radio links therefore. And the third target group is consumers, which are interested or might be interested in retraceability, which is related to documentation and additional information about the product they want to buy. So this is the general structure of the experimental field, and I will dive into some activities. And now you can imagine, or you can for yourself imagine where on the cube which activity is lying in. One activity is concerning sensor networks. Here you have a basic structure of the sensor network. These are especially the linear sensors, like a temperature sensor, rain sensor, or sun radiation sensors, leaf wetness sensors, but also actuators, for example, valves or pumps for irrigation systems. And it's a specialty of what is special about these sensors is they are have a real low power consumption. So there is a small battery inside, which is enduring several months or even years. And they have a long-range communication. So compared to the small energy they need, they have a long range with the radio link. This is made because they only send their data for very short moments and then have then they are silent for some time, and so the relation between sending time and standby time is very in favor to the standby time. And it's also typical for these sensors. They can be driven in both directions. So that's why it is possible to have actuators as well, and it is possible to control these sensors. So there are several sensors distributed in the area, which are all communicating with a LoRaWAN gateway. And this gateway collects all the sensor data and is connected to the internet as well, as you can see in the chart. And on the other side, there is a dashboard or different applications which can access these data of these sensors and do analysis on them. So this is the example here in Geisenheim. On the left side, you see all those sensors. These are the sensors already installed, but not yet LoRaWAN. So these are sensors you need to go there and need to get the data from the sensor directly. This means you need to go to every sensor and pull the data out of them. These sensors will be replaced by the LoRaWAN sensors, and 2 gateways are needed to cover all those sensors. And some new fields or new areas will also be covered with these LoRaWAN sensors, and you can see you get a high spatial resolution. If you have several areas, you can all equip them with those sensors, and with one LoRaWAN gateway, which will be positioned at the Department of Viticulture, you can cover all the sensors in a circle of 2.5 kilometers. So these sensors are very interesting to run real-time models for example, irrigation scheduling, or pest and disease control, or decision support tools, etc. It's also very easy to share the data with project partners or producers or services, because it's all available via the internet. So another activity is, I call it here, multispectral and 3D measurements. So the LoRaWAN network, the sensor network, is more or less to get a lot of data, I would say, around the plants, climate data, soil data, air data. And the second activity is aiming to look into the plants, kind of. So we have we are building a multispectral camera with 16 channels with very high resolution, 5 megapixels each. Depending on the distance to the target, we can reach even a couple of millimeter resolution. These spectral bands are used to calculate or to verify or search for new indices. This is combined with the 3D LiDAR scanner, which has Anna already explained. But this LiDAR scanner will be installed together with a multispectral camera on the drone. So we can do frequent flights and have high resolution 3D point clouds. And this is combined as well with photogrammetric procedures, which give better optical impressions. And so with the combination of these sensors, we can kind of look into the plants and find conclusions about their health status, or maybe dry stress or diseases which are coming. There is also a hyperspectral camera available for deep insights if something has to be examined, especially exactly. There are as well high performance graphical processor units to combine all those channels and all those data to get data cubes. And this is the aim is to do this online, so that during flight there is already a pre-processing of the data to get online information about the plants and canopy density and leaf area of the canopy, etc. Here on the bottom, you can see the available filters we have for this 16-channel multispectral camera. Third activity is precision plant protection and fertilization. So this is some ways in common with what Anna told us. There is a first procedure. I call it the offline procedure. So in the first step, the drone will fly with a simple multispectral sensor. It's a 5-band sensor, the Altum. And after that, the data will be evaluated, and there will be created fertilization or plant protection maps, which are loaded onto the drone. The drone is getting the route to do the specific plant protection. And so this is an offline procedure. but it's previewed to do this online, as I've told, using these sensor of activity of the second activity. So the sensor data are evaluated on board of the drone, and also decisions on application rate are taken. And the variability of the application rate can be realized with either a spraying system with which is adjustable in the flow rate or pressure, or on another method would be to change the speed of the drone. Here are some impressions of the aspects of the precision plant protection and fertilization as we understand it. On the left side here we have a filling station, which allows us to very precisely mix the plant protection agents and to do the transfer into the drone, also with exact quantities which are presettable. And all this can be contamination free for as well environment as well as the user. On the right side, you have the equipment on the drone. On the bottom here is the spraying system controller. It's a system Clever Spray from Innovel. On the top right corner here you have a bigger image of the professional flow sensor and pressure sensor, which is used to get specific spray rates. And here an impression of what is already done. On the bottom you can see the possibility the drone can be programmed to spray specific parcels of an area. There above you can see the documentation. Here is everything carefully documented: pressure, flow rates, used agent. This is locked together with the position, as you can see here on the downside. And here you can even see when turning or changing row, the spray system is switched off, and this is also locked in high resolution here. Here on the right side is a quick evaluation of the Altum sensor. You can see you can build different indices, for example NDVI, as you can see here, which can be used for the decisions how to fertilize and how to do the plant protection. Another aspect of this precision plant protection and fertilization activity, this is especially done of the Department of Enology, is they establish a sampling strategy in a fertilization trial. They do laboratory measurements of nutrition states and health states, and do with a spectrometer vehicle do the measurements with a spectrometer. And here is a kind of overlay. We can see there's a good agreement between the leaf analysis between the analysis of the leaves manually done and the sensor map done with the spectrometer vehicle. There is not everything directly corresponding, but you can see that here a very good agreement of these areas. In these on this special area also was done one flight campaign with the drone, but this is not yet evaluated. It will be interesting to see how this will correlate to the pictures we have here. Another aspect is there is an industry partner that would like to show or try his precision fertilization sensor. This is a ISARA sensor. And this is the outlook for 2021 to do a setup in the fertilization trial and compare with the results of this ISARA sensor. A fourth activity is the drone control. to increase the efficiency or the area capacity. What can be done on one day? There are two means to increase this. One thing is increasing the size of the drone. Another thing is to extend the possible region of operation. So this means operation in BV loss manner, meaning beyond visual line of sight. And if a drone gets more heavy, it's more risky, and there are more requirements to minimize the risk. The same is for BV loss operation. So one thing under others is the drone absolutely needs to be connected to air traffic control. This is realized in our case with a UTM, meaning UAS traffic management, which is operated by the Deutsche Flugsicherung. And there are two ways the data from the drone get into the UTM or to the DFS. One is a hook-on device. You see on the left side, this is a device in size like a cigarette package, which can receive FLARM and ADS-B signals, and has also a GPS sensor you can see, and has a LTE connection. So this device can receive and send those aviation signals, and can send them via LTE to the UTM system of the DFS. And there is a second system, they call it GBSAS, a ground-based situational awareness system. This is a similar thing like the hook-on device, but for stational operation. This has a much more a bigger distance this can cover. This is also connected via internet to the UAS traffic management. And with these systems, the DFS is informed about what is the drone doing, what is the course of the drone. And also there is a back channel. The drone operator can log into the UTM system and can see what other aircrafts are in the air around my region of operation. This connection of the drone is extended by this quite a bit complex graphic. As you can see, here in the middle we have the drone. The drone has a flight controller. On the drone is installed the hook-on device I described before. And the hook-on device and the flight controller are connected to the internet via mobile network, 3G or 4G. This is the remote control of the operator. In general, we also have a laptop near the operator for mission planning or getting extended data about the drone, telemetry data. Telemetry data and remote data is going on this radio link. And now when we want to operate the drone beyond the visual line of sight, or when we operate the drone in areas where there is not really a good mobile radio network coverage, and you can see there is a problem because all those connections get lost. And this is the idea. We need additional radio links, which are realized with two kinds of satellite communications. There is one based on Iridium. These are satellites circling around the Earth. The advantage of them is you can have mobile antennas. So there is a hybrid modem on the drone installed as well, which is connected to the flight controller. So it can transport data to via the Iridium satellites into the internet. So there is the link re-established. And this is a two-way communication. The UTM system also can give commands the back way to command the drone, for example, to land or to return to home. There is another satellite system. This is a geostationary system. Astra satellites are well known from television. The advantage is a very high data rate, and it's not that expensive. But the disadvantage is you need a ground station which shouldn't move that much. So you have here this box, and you place it somewhere, and there are 5 minutes needed. So this antenna is standing up and is searching the satellite and directing itself precisely to the satellite. But thereafter you shouldn't move it. So this cannot be installed on a drone. It's also too heavy, as you can see. But the advantage is this system is setting up a WLAN hotspot, and the flight controller and the operator's personal computer are connected via WLAN to this satellite antenna, and so you have a quick or fast internet connection via satellite, even if you have no mobile coverage. So this is necessary and sensible for autonomous flights and for drone tracking, and it's quite a challenge to realize the communication between all those systems. Fifth activity is, I call it here, economy and interests of consumers. So questions to be which are asked and to be answered are: is the use of drones economically reasonable for fertilization and for plant protection, for example? It's a challenge. It's a question to estimate the possibilities of saving plant protection agents and fertilizer using the mentioned high-quality sensor data and artificial intelligence. So it's a bit different from what Anna described. Here is the focus more on not to distinguish between trees and the vineyard areas, but to find the difference between healthy areas and unhealthy areas. So a related question is, would be nice if the helicopter could be replaced for plant protection. And for the consumers, this is our third target group, as I mentioned at the beginning. Is there a demand for precise production or for extended production documentation? And if the consumers say there is a demand, will the consumers really use the information, or is it kind of like with organic products? A lot of people say, "Oh, we would like it," but in reality, they won't buy them. So have we say some similar aspects here or not? And to answer this question, there is an extended online web shop created to test the behavior of the consumers concerning these aspects. So for my conclusions, as I've explained, it's a quite multidimensional project. Currently, the focus is still on the viticulture, but wheat and canola and orchards trials are planned. A lot of the necessary preliminary work is done, and there are several cooperations with industrial partners which are really interested and are delivering interesting products. And the equipment acquisition is finished for now, and we are really looking forward to 2021. So for me, rests saying to thank you for your attention, and if you have questions, post them. Thank you very much.
Thanks to you, Dr. Brunner, for providing us with a detailed insight into the activities of DIWAKOPTER. So are there any questions or comments from the audience? Please go ahead.
Yes, I have a question. What's about the permission you need for the copters? Is it really important that you have a redundance system using, on one hand, Astra and on the other hand, Iridium?
This is a very broad discussion topic. At the moment, it's all not yet clear how this will come out. It's clear these are drones that are quite heavy. Most of them are more than 25 kilo. And we need to look what can be done to support or to minimize risks. And the satellite link is an additional security factor for one side, and on the other side, it's especially in country-like regions, there is often not a really good coverage of the mobile network. And if you lose the mobile network, you lose everything. And so this is the trial to find a backup for this. It's not only especially necessary for the drone. We are, besides of that, interested because we have the impression this is quite an interesting system, completely independent of the drone. If you operate things where you would like to have internet, but there is no network coverage, you are lost. And with these satellite systems, which are not really that expensive, there could be quite interesting applications, and so it's also a topic in the project. Is this technique usable? In the
Mm-hmm. I understand that quite well, but give me just an idea about the money you have to pay per 1 gigabyte using perhaps Iridium. Maybe it's a better way than to use 5G, or is it not true?
This is why I have explained both systems. Now the bytes per the payment per gigabyte for Iridium is much more expensive than the bytes per the payment per gigabyte for the Astra satellite. As far as I understood, in the Astra satellites, it depends on the agreements. There are even chances you can, during the night hours, get data without paying. So it's quite an interesting thing. On the Iridium side, here is the advantage: you can have the modem on the drone. This is small and it doesn't need the precise direction. But there is the payment more or less on kilobyte base, and so this is only interesting for telemetry data of the drone, which are only some kilobytes per second or minute. Whereas with the Astra system, you can even think about transmission of video or extended data from our multispectral sensors.
Thank you for the answer. I can see that Mr. Boban Ilic from our partner standing working group in Macedonia also raised his hand, so please you can ask your question.
Okay, so thank you, Peggy. First of all, congratulations, yes, for organizing this video, how can I say, workshop, chat, and presentations, and so on. I'm not an ignorant one, or I'm agronomist, and listening to these two presentations, practically I found myself like a little bit very hard to go through all these abbreviations and so on. So I guess I have to update myself with this modern vocabulary. First thing I've noticed, and this is a general, how can I say, observation. I'm participating in different global, so to say, discussions and regarding the digital tools within with agriculture. And what I was waiting the two presentations, so maybe I could wait a little bit more. No one is using the how can I say, the expression digital agriculture, digital viticulture, and I'm very glad to hear that, because that is the kind of a new vocabulary within the sometimes, you know, unexperienced people are talking about digital agriculture. For the moment, what we are here listening is digital applications within the different aspects of the viticulture, consequently other segments of agriculture, which is for me it's a philosophical question, because it is bringing some new technological, so to say, solutions for certain problems in production, in traceability, in handling the. So that is the first thing, and thank you for that, because maybe this is too far from this technical discussion, but again, you reconfirm the position, which also I personally believe it's true. We cannot talk about the digital agriculture or digital viticulture. Viticulture is a biological process, full stop. Digital tools within, how can I say, production are more than welcome, and you just reconfirmed my opinion. Maybe a question now. So this was a general comment. Question to how, for example, okay, certain aspects of the first presentation are, how can I say, are going into that precision agriculture, so to say, terminology and so on. How to apply the, hello?
Yes, we can hear you.
Okay, how to apply all these, how can I say, technical solutions on very small plots, such as in the Balkans. Okay, we have very small, how can I say, plots. I don't know, in general, in agriculture, it is between 1 and 2 hectares in principles. Okay, I think in viticulture, they're even smaller. So is there any limit? Because precision agriculture, per se, cannot be applied on such a small plot without too high costs. But please tell me, in viticulture, how do you see the applicability of all these digital, let's say, solutions in the area where the vineyards are very, very small? I saw on the photos how it looks like, but if you can maybe just give additional explanation. Thank you once again, and again, congratulations to all of you who organized this discussion.
Thank you, Boban. So can we already answer the question? Because I think it is really important, because we are talking about research projects funded by the German ministry, but in the end it shall support producers, right? So is there anybody willing to answer this, or shall we go to the next presentation? Because then we will have the chance also to hear a producer's perspective on the projects.
Maybe I can give you a short answer. The answer is because we are here in the east of Germany, and we have a very small structure of hobby viticulture specialists. And the problem now for all of them is they have to show up that they have the right knowledge in application of plant protection. And they have to have enough time left to do that during their normal jobs. And so I think in this case, it's very efficient to use the drone and to use the drone for plant protection, because you need just one person or two persons being involved in the knowledge of plant protections, and you can't spray the wrong things normally, and it is economically quite sensible to use the drone on even such small limited areas. Thank you.
Maybe I can give a small statement too. So the thing I showed you about the protection of non-target areas, that can be done also for the small vineyards, for small areas, because in Germany we also have only a few acres or a few hundred vines, and then they are like segregated over a big area. So that is also a problem that we are facing, and so that web service will work with any size of vineyard area. So it could be 1 hectare or 1 acre. So it would work with small ones too.
I've just one question left. The question is, if you take, for example, the best time for plant protection, it's during the night. So the question is, have you any experience about the drone flying in the night, or have you got already a permission to do that by the authorities? Because I think this will be the most important time for precision plant protecting.
We made, but this was another thing. We made some trials by night because we made examinations with fluorescent colors in the spray liquid and special lamps, which we switched on in the night and filmed this to see how the spray is distributed. For the drone itself, the drone doesn't need to be seen. The mission of the drone is programmed into the drone, and the drone doesn't mind if it is night or day. This is independent. Concerning permission, I'm not sure if there's really a difference. At the moment, it's anyway quite difficult to say how will it continue with new EU regulations. There is a lot of discussion and not everything final at the moment. But for the drone itself, it doesn't matter if the drone doesn't need light to fly. And another question might be if you want to use the sensors I described, there might be a necessity for light. Because I'm not sure if there would be, one should think about if it would be possible with the limited energy on board of the drone to drive strong lamps. Maybe this would be sufficient. I'm not sure what performance would be needed of the light.